Welcome to solverfy.
Okay, so in this problem, we are given with a sample of a salt named Epsom salt, and which is written as MgSO4.xH2O, where X indicates the number of moles of water per mole of magnesium sulfate. So here we're given a mass of this MgSO4.xH2O or Epsom salt, which is 5.061 gram. And when it is heated, all the water of hydration is lost, and this mass of magnesium sulfate is left. That means this is the mass of magnesium sulfate in this formula, and where this is the mass of the whole formula. So we have to find the value of X. That means we have to find the number of moles of H2O present per mole of magnesium sulfate. So as you know that to find out the number of moles, we have to um, what we have to do is we have to just divide the mass by the molar mass. So here we know the mass of magnesium sulfate, we know the mass of the uh, formula. So from these two mass we can find the mass of water, and we know the mass of magnesium sulfate. So from these two we can find out the number of moles of H2O and magnesium sulfate, and from there we can find out the value of X. So here are the steps written down here, which we'll follow in this problem. First, we'll calculate the mass of water in the salt, and then we will find out the number of moles of water and magnesium sulfate. And then we will divide each of this number of moles by the smallest number of moles of this. Which one is smallest? We just divide both of them by the smallest one to get the simplest whole number ratio of the moles. And from that ratio, we can identify or determine the value of X. So let's start by finding out the mass of H2O. So mass of H2O will be equal to mass of the sample or mass of hydrate minus mass of MgSO4. So our mass of hydrate here is um, this one, which is 5.061, and our mass of magnesium sulfate is 2.472. So we right 5.061, which is the mass of hydrate, minus the mass of magnesium sulfate, which is 2.472 gram, and this will give us a value of 2.589 gram, which is the mass of H2O here. So now we have found the mass of H2O, and this is our mass of magnesium sulfate. So from these two we will find out the number of moles of H2O and magnesium sulfate. So number of moles of H2O will be the mass of H2O over H2O smaller mass. So the mass is 2.589, and the molar mass of H2O is 18.01, as we know, um, gram per mole. That means it will give us a value of 0.144 mole. So this is the number of mole of H2O. Now we'll find the number of moles of magnesium sulfate. So number of moles of magnesium sulfate will be the mass of magnesium sulfate, which is 2.472 gram, over the molar mass of magnesium sulfate, which if we calculate we'll find 120.4 gram per mole, and this will give us a value of 0.021 mole. So this is the number of mole of magnesium sulfate, and this is the number of mole of H2O. So from here we can see that this is the smallest value. That means we will divide each number of moles by this 0.021 to get the simplest whole number ratio. So the ratio of H2O will be the number of moles of H2O, which is 0.1438 mole, over the smallest mole, which is 0. Okay, we consider that as 0.144. We'll write it to here also. And we'll divide this by 0.021 mole. It will give us, so it will give us approximate value of 7. And then in case of magnesium sulfate, since we are dividing the same number 0.021 mole over 0.021 mole, so this will give us a value of 1. So from here we can see that the ratio of H2O and MgSO4 is 7:1. That means for 1 mole of magnesium sulfate we will have 7 mole of H2O, and this is the value of X, as we know that the X is the number of moles of H2O present per mole of magnesium sulfate. That means since we have 7 mole of H2O per 1 mole of magnesium sulfate, that means the value of X is 7.